Imagine looking at the night sky and realizing every twinkling star has its own life story, a beginning, a middle, and an end. Some live billions of years, quietly shining in the darkness, while others die in the most violent explosions the universe has ever seen. This is not just science. It's the greatest cosmic drama of all time. Today, we uncover the life cycle of stars, how they are born, live and die in spectacular fashion. The story begins in the darkest regions of space, giant clouds of gas and dust called nebulae. These are stellar nurseries, the birthplaces of stars. Gravity plays the leading role here. Over millions of years, gravity pulls hydrogen gas together, forming dense clumps. As these clumps grow heavier, their cores heat up, reaching temperatures of millions of degrees. At this moment, the miracle of fusion begins. Hydrogen atoms fuse to create helium, releasing massive amounts of energy. And just like that, a star is born. This newborn star enters what scientists call the main sequence stage, the longest and most stable period of its life. Our Sun is in this phase right now, and has been for 4.6 billion years. In this stage, a delicate balance exists. The inward pull of gravity is perfectly matched by the outward push of energy from nuclear fusion. This balance keeps the star shining steadily for billions of years. But not all stars live the same way. Size determines destiny. Small stars, called red dwarfs, burn their fuel slowly and can live for trillions of years longer than the current age of the universe. Medium-sized stars, like our Sun, live for about 10 billion years. Massive stars, however, burn their fuel so quickly that they live fast and die young, often surviving just a few million years. Eventually, the hydrogen in a star's core runs out. For a medium-sized star like our Sun, this is the beginning of the end. The core contracts under gravity, while the outer layers expand, turning the star into a red giant. Imagine the Sun swelling so large it engulfs Mercury and Venus, maybe even Earth. It's a terrifying thought, but billions of years away. Inside the red giant, the core gets hotter and begins fusing helium into heavier elements like carbon and oxygen. But this phase doesn't last forever. When the helium runs out, the star can no longer fight gravity. For Sun-like stars, the outer layers drift away, forming a glowing shell of gas called a planetary nebula. At the center remains a tiny, dense core, white dwarf. This white dwarf is only about the size of Earth, but contains nearly the entire mass of the star. Over billions of years, it will cool and fade, becoming a black dwarf, a cold, dark remnant. But the fate of massive stars is far more dramatic. When a star, many times larger than the Sun, runs out of fuel, its core collapses violently. In a fraction of a second, it triggers one of the most powerful explosions in the universe's supernova. For a brief moment, this explosion can outshine an entire galaxy. Supernovae are more than just spectacular. They create the elements that make life possible. Gold, silver, iron, all forged in the hearts of stars and scattered into space when they die. Every atom in your body was once part of a star. Sometimes, the core left behind after a supernova becomes a neutron star, a city-sized object with the mass of the Sun. A teaspoon of neutron star material would weigh billions of tons. If the original star was even more massive, the collapse continues until not even light can escape. This is how a black hole is born, the most mysterious objects in the universe. So what does this mean for us? It means the universe is constantly recycling itself. Stars are born, live, and die, creating the elements that form planets, oceans, and life itself. In a very real sense, we are all made of stardust. The calcium in your bones, the iron in your blood, Even the oxygen you breathe all came from stars that lived and died billions of years ago. The life cycle of stars is more than science. It's a story of transformation, destruction, and rebirth, a cosmic circle of life. And the next time you look up at the night sky, remember this: every star has a story, and in its light, you are looking at the history of the universe.